darks both day and night. It's full of dark and light, and I've heard others call from light years away. Instantly clear, planets spin, grids in place. We can travel through space, fields and forms, math and voids. It all seems with one voice. It's home. Boundaries set, foundations laid. Sound was heard, matter made. Solar systems from afar. Names and numbers for the stars, and I've heard others call from light years away, and they're real and they're here. Space and time are instantly clear. Planets spin, grids in place. We can travel through space. It's the Lord's.
Well, hello everybody. Welcome to SkyTour LiveStream. It is, who am I? Oh yes, me. Mark D'Antonio here with Daryl Mason. Hey Daryl, how are you?
Hello Mark, I'm good. You? Hello everybody.
I'm doing good, thank you. Daryl said it was pretty hot where he was today. You said 90s?
Forecast was 93.
Wow, that's pretty warm.
I don't think it quite hit 93. I could be wrong though.
Wow.
But I saw on Weather Underground,
Holy
when
cow,
I checked
that's...
the weather in Arizona, it was over 100, 103 or something.
Yeah, it was like 106 the whole time I was out there. You know.
Yeah.
Nice flight back. Must add to Tim F, who was first, Daisy and Zoe Amethyst. Judy M is with us. Hi, Judy. And so far, we got Ricky Ricardo with us as well. And so far, that's who's here making themselves known. But we're gonna have some fun tonight.
Did you say hi to Rockstar?
Is Rock here? I didn't see him.
Daisy and Zoe and
yeah, I just did. I said hi to Daisy and Zoe.
Okay.
Oh, there's Rockstar. Rockstar 8970 Abel. How you doing? Nice to see you, man. We are here, and Justin Langford is with us. Hey, Justin. If you're a first timer, please do subscribe. We will be checking out some cool things. We're going to go into our planetarium here and zoom out a little bit, and we're gonna let it get a little bit darker out there. But in the meantime, we're gonna try and locate a couple of cool galaxies, namely NGC 4565. Here it is. And check those.
Before you go there, you're so close to Spica, hop right over to M104.
Well, it's not dark enough yet. I was thinking we'd wait till it gets a little darker.
Okay.
Only because, the Needle Galaxy is bright enough. M104 is a little bit fainter, isn't it?
It's pretty bright.
Okay.
They're probably comparable. I don't know.
Well, we can hop back in just a minute.
All right.
Right now, we still have sunset light out there, as you'll see. We're gonna move the telescope over there right now to the Needle Galaxy. That was our first one we were thinking of for tonight. You'll see the stars moving. You'll see the telescope moving right over my head. Okay, it's heading almost directly straight up. And it's going to be looking at the Needle Galaxy, which looks like it's right there.
Yep.
Yeah, and we'll center it up, and then we will zoom in on it. So here we go. I focused the telescope already, but we may focus again. We are fighting a few clouds today, and I'll give you an idea. If we go into our all sky cam, you can see it's just getting a little darker. I'll turn off the constellations. This is that transitional mode where the exposure is too bright because it's still got daytime going on, but it's a nighttime exposure. You can see it says night up here. So it'll get a little darker. Right now we're okay, but we don't want to spend too much time playing around because there are some clouds that may be coming to endanger our view tonight. We shall see. That said, let's do this now. Let's move ourselves down here. Papa Tom, what's going on? Nice to see you. Yeah. All right. So, and let's move a little bit west here, and this way our telescope will start getting a lock. All right, there's the center point, and we're pretty well centered there. Okay, and now once we start to see numbers here, we're guiding, so we're going to do that. There we are. Now what we're going to do is we're going to take a 20-second shot, and I say 20,000 because that's the 1,000 milliseconds per second. All right, so there we go. So now what we're going to do at this point is we are going to take this picture, and this is our low light view, so you can kind of see a little bit of the galaxy, but we're going to come out of the low light view and go into our high definition stack view and get our stack to start up here. You can see the progress bar in yellow down here in the lower right. That progress bar, okay, which is right here, tells us that our exposure is underway. And when that is full, we look back here and we see that came in, and what we're going to do is color correct, and there's our galaxy, and we're going to actually do a little bit of correction here, and we're going to do a little color correction here. We're going to remove color noise. Watch how much better it gets instantly, just like that. Look at that. All right, the red fringing, that is due to the sunset light. But even with sunset light, we can actually take photos. Isn't that crazy? Here's a Starlink satellite blazing through our view. You can tell by our spider web, we're getting some winds, desert winds here. I should actually put a little flag inside the building so you can actually see that instead of depending on a spider. We pay him a little to build the webs, but, you know, he doesn't always build a web on time.
Hopefully he eats any bad insect critters in there.
Oh, he does.
That's why I leave spiders alone.
Well, being that he's a black widow, I think that, or she is a black widow.
Oh.
Yeah. She's out living up by the camera. I don't mind, you know, as long as we get rid of our insects we don't like. All right, so there's a black widow living down under the floor, not under the floor, but under the stoop to come in. All right, let's move our dark up the curve here. And you'll see when we do that, the sunset light is really obvious here, so we have to color correct again. Get rid of some of it. Like that.
I was reading the other day, I saw a nice picture of 4565 here. Very similar to our Milky Way. It's about 100,000 light years across, and obviously we're seeing it edge on.
Yeah.
And I've said this before, that if you could tip the galaxy about 90 degrees clockwise, so that lower left leg is pointing to the upper left, and then you made an artificial horizon just below the central bulge, it would look very much like our Milky Way.
Yeah.
In Earth sky.
Yeah. Just farther away.
Yeah.
Hello, Sam S. with us. Nice to see you. Very cool.
I heard something else the other day. I haven't looked into it closely yet. Somebody came out and said that the Milky Way galaxy is 10 times bigger than we thought it was. I don't know whether to believe that. Milky Way is supposedly 100,000 light years across, and 10 times bigger would make it 1,000,000 light years across, and I find that hard to believe.
Yeah, me too, because the Andromeda Galaxy is not that big.
Yeah.
And the Andromeda Galaxy is estimated to have over 1 trillion stars in it.
There you go.
Let's move our thing here. To understand these curves, we have a red, green, and blue curve. The color correction curve, see if I move this color like red, if I move it, look, there goes the average, because the red curve has now gone way down here. So the average between the red, the green, and the blue, which are coincident with each other, is that. So if I move the green around, now you have red, green, and blue, and the average is right here in the middle. So if we move these curves up, all right, then what you'll get is we bring these curves closer, all right, to each other. And if we color correct, then we have the average. Right now, that's the real color. All right, so this white curve represents the average of all the data curves, and this dotted line represents where we are starting to pick off the data. If we're way out here, we're way to the left of the data, and so we're just getting white noise in here that isn't really there. And if we bring this over to the curve and start going up the curve like this, like here's the white curve, we start climbing the curve, we're going to get to the near the very top, where we stop just shy of the top. Right about here. This is about as dark as you want to get. And this curve is the midline curve. If we bring this closer, you see how the yellow curve that dictates how much we're getting starts to get closer and closer to the rest of the data. You'll see that we're pulling in more data like that. And this is pulling in what's under this curve right here. So this is what we're seeing here. So that actually does that. When you pull these two lines close together, that's called a push. You're pushing the processing, trying to get more out. But usually we start way out here, okay, and we color correct, and so you see the much more pleasing view like that. Now, NGC 4565 is interesting because, watch this, when we annotate this, okay, we're going to just do a whole sky annotation. It's going to capture and identify what it sees in here, including stars if they're bright enough. And this is neat. So here you'll see what it's going to annotate.
You had a nice exposure going a little bit ago where you could see a little more blue out in the spiral arms.
Yeah, it's a matter of adjustment. We can get that. All right, so here, check this out. All right, each of these IC numbers here, I bet you didn't realize there were so many galaxies in this image. But there are. Everything labeled is a galaxy. Look at that. IC is index catalog. These are all galaxies, and some aren't labeled because they're different catalogs that are not in this database. But that's pretty cool. Now, they're labeled as stars, but I'm not sure why an IC catalog number would be a star. I don't believe it is. But we got lots and lots of galaxies in this view. It's really incredible. So let's let me color correct this again. And after color correcting, I'll bring this down right about there, and I'll save the annotation, but I gotta first name it. So this is NGC 4565. All right. So there we go, and I'll save image with annotations. Okay, there we go. So that's saved. Now we know what we're looking at. So we can come out of here. You can see blue out here now. Let's see if that's real. Let's go and pull back to just the left of our peak here.
It's real. I was going to comment when we saw it before that it really showed the difference between the yellow stars closer to the center of the galaxy and the blue young stars out in the edges of the spiral arms.
Right. So if we zoom in, you can see these have a blue tint to them, a little bit bluer. And these are yellower. Older stars, younger stars tend to be blue. Ranjit says, amazing dust lane details. Exactly so. Ranjit, thank you for noticing that. Tricia Ferreira, how are you? Okay, we've got 23 images saved here. We actually still have the sunlight, the daytime sunset still going. But it's testament to the fact that we're filtering out a lot of stuff we don't want to see that makes it able to be viewable like this. So this is cool. All right, let's see now.
That's pretty nice there.
Yeah, it's going to, you can see the blue very clearly. I'm going to keep moving this to the left side of the data because I want to soften the noise that we see in there. Really cool. Remember, if we zoom out, we've got a lot of field here. And you see a lot of the red from the sunset here. But if we pull into the center, you don't see too much of that. And the color correction will remove most of it.
One of my favorite galaxies.
Yeah, it's beautiful. Mr. Django, what's going on over there in Belgium? How are you? I announced we'd be doing the stream tonight, but only in SkyTour LiveStream and on my personal page. I didn't, well, in one of the Astrophoto group. They have 1.1 million people in it, so someone's got to be watching.
Hopefully.
Yeah, if any of you are here from the Astrophoto page, let me know. Group page. And 4565 is just a gorgeous galaxy. You know, if we look at it and get close to it here, I'm going to align with it better. This galaxy is a spiral, so it has a capital S as a designation, and an A, meaning that it's a fairly tight spiral. Ours is not a tight spiral. We're less than that. We're a barred spiral. But 4565 is not a barred spiral. It's a straightforward spiral galaxy. Although that beautiful central dust lane is absolutely stunning.
Yeah.
Yeah.
Tom asked, what's the bright center? Is that a large star?
Actually, I'm not sure if this is a star in the foreground.
It's, I do believe it's galaxy.
You think that's the galaxy?
Yeah, it's the core of the galaxy, the nucleus.
It seems off-center, but I see your point. Yeah, it could be. You're right. I have to look at other pictures to see.
And Papa Tom then says, does it have a black hole? Probably.
Yeah, most galaxies, Tom, seem to have a SMBH in the middle of supermassive black hole. That is just seemingly par for the course for these large galaxies. But yeah, we may find that supermassive black holes are the way of things when it comes to large galaxies, or any galaxy. I mean, dwarf galaxies aside, dwarf galaxies don't typically have as much structure, so they may not have a black hole. But these galaxies, the regular spirals and barred spirals and ellipticals, these will have a supermassive black hole at their center. All right, let's. It's only a 20-second exposure, but that's looking pretty, huh?
Mm-hmm.
All right, let's save it right now. So right now we're saving the FITS file, which is an astronomical file format. And then we'll save it exactly as seen, which is the ping file. And I think Lane is here too, correct? Yes, Lane is with us. That's great. If we can keep her away. Oh, come on, Lane. I'm talking to you directly. Daisy and Zoe, where are you located? What state are you in? Let me know. I'm in Connecticut right now. The telescope's in Arizona, and I'm running it from Connecticut. I'd like to know where Daisy and Zoe Amethyst are located with Lane. Look at that. That's beautiful. We're going to save that again because that's really pretty. They're in Delaware. Okay. Reminds me of a joke. What did Delaware to the ball? The answer is Idaho, Alaska.
That's not funny.
Well, it's funny. I've been to Delaware quite a few times, driving to Washington to do Navy work over the Dover-Delaware Bridge. Really pretty. This is good. 40. Okay, we're going to stop here on this one. And why don't you go get me the coordinates of the Comet, because we're going to check the Comet again. And we're going to also check T Core Bohr.
You want me to go get coordinates? Is that what you said?
Sure, because that saved me some time, and folks, you can be getting them while I'm doing this. If you'd rather not, I'll do it.
Oh, that's all right.
All right. So that is that guy. That's pretty cool. That's a really pretty one. All right, we're going to go into our low light mode again. And here we are. See how in low light it shows up barely visibly. All right, and we'll come back in. And let's now
Uh,
Oh, you got them already?
no. I went to the Sky Live. I figured they'd have it up in the highlights, and it's not there. So I
No.
guess I could look for it the hard way.
It's not there?
Not in the highlights.
Can't
What's it called?
be.
C3.
C 2023 to Tsuchin Shan Atlas. Yeah, it's right there. It's right in the middle. I got it. Never mind. Thank you. It was easy to grab. I didn't know it was gonna be this easy. I went over to grab it.
Fine.
All right. Thank you. All right, put that in.
I tried.
You did. You did, and it was just a little bit of a pain in the butt.
You'll miss me when I'm gone.
All right, we'll do this one and that guy. All right, and now this one. Oh, that's fine. All right, now we'll say go to. And we should be able to find it pretty easily.
Still in Virgo?
I believe it is, actually. Let's go see.
I think it is.
Yeah, it is.
I think it's gradually moving toward Leo over time.
Yeah, here it is right here. Let's bring it in. All right, let's go to the east. Go to the east, bring it into the center.
So where did you find the comet? Just in Stellarium?
Oh, it's the Sky Live.
Oh,
You scroll down a little bit, and it's right there in the center. It's in the biggest type. I'm sure you'll see it. All right, good point. There we are. All right.
yeah, there it is.
I know, right? Isn't it? Sometimes you can look.
Well, it was mixed in with all those other words.
I know, and it looks weird.
I didn't look.
Yeah. Cosmic Ray once again saying things that are beneficial to everybody. All right, I'm going to go to the stream here. I'm going to go to do a 20-second shot here. Just to get a look at this. We're going to come out of low light mode, go into our stack mode. And the last thing we saw was 4565, which will show up. Here it is. And we'll clear this. Okay. And in it comes. Now, while we're waiting, I'll just quickly show you all. This is our telescope control. This is our telescope computer. These are the two views of the telescope. This is me. And this is the camera control section here. That's the exposure. This is the gain. These are the two most important parameters. Then this is the focusing section. And this is our stack dialog down here that allows us to literally do all the stacking and reject bad images that do not meet our stacking standard. And now we'll get the Comet. There we are. Look at that. The Comet's getting more detailed, by the way. I noticed the other night that it actually has a longer tail than it had before. And you gotta kind of stretch yourself to see it, but it's out here more. And I suspect the tail's going to get longer as time moves on here.
Did you see the pictures of Comet Pons Brooks the other day?
I did not. But Ponds Brooks, we can't see because it's so low for us.
Well, I know, but they can still see it down in the southern sky.
Mm-hmm.
It developed an anti-tail.
Oh, that's cool.
Really cool pictures. The Earth is passing through the plane of the dust tail. Not we were passing through the tail of the comet, but we passed through the plane of the tail. And when that happens, that's when you see a big anti-tail form.
Mm-hmm.
The gas tail was pointing one way, and the dust tail was pointing in the opposite direction.
Yep.
Really cool looking picture.
Yeah, and it happens because we're looking at the universe in 3D, so we're only seeing a 2D projection on the sky, as you're alluding to, of course. So it's crazy. The anti-tail is always pointing away from the sun directly, and the dust tail is just following the comet's path. So it's interesting how the anti-tail can point the opposite direction of the dust tail.
Say that last part again.
The ion tail. The ion tail. Are you talking about the anti-tail, which is the dust tail projected along a different plane, or are you talking about the ion tail?
I'm talking about the dust tail.
Okay, yeah. All right, sorry. Genghis, how you doing? Curtis Horn, how you doing? This is indeed 2023 Tsuchinshan Atlas. There it is on the screen. 2023 A3 Tsuchinshan Atlas.
Genghis has a good question.
Genghis. All right, what does Genghis have to say? So I see an article, James Webb Telescope finds carbon at the dawn of the universe, challenging understanding when life could have emerged. Is that something you... Oh, sure. Carbon is the fourth most abundant element in the universe. Oxygen is the third most abundant. So it stands to reason that earlier formation of carbon would make sense. Now, first of all, you got to understand where carbon comes from. Carbon comes from two places, nucleosynthesis, and it comes from formation of carbon in the outer atmospheres of large supergiant stars. You can get actually molecules, carbon-carbon molecules, two carbon atoms combined, in the outer atmospheres because it's relatively cool out there compared to the center of the star where it's too hot to even have atoms. But in the outer atmosphere, temperature is only about 2,500 Kelvin, so it's very possible to actually have a situation where you can actually have molecules of carbon form out there. That said, the carbon forming or being found to be in the early universe indicates that a lot more star birth and death might have occurred, and or in addition that there might be a number of additional carbon atoms that we just did not know were formed in the early universe. So that's very interesting. Now, most likely it has to do with the supernovae, and not the because when carbon's formed in the hearts of stars, okay, supernovae are going to release a lot more carbon than the dust in the outer atmospheres of the supergiants. Okay, so even though the supergiants are going to go supernova, the carbon, the helium to carbon fusing process takes place in giant stars that have gone to red giant stage more than twice. Once they reach that second stage, they're already making carbon, and that's in the asymptotic giant branch, it's called. So when a star runs out of hydrogen, it swells up into a red giant. Okay, then the temperature gets hot enough in the core to start fusing helium into carbon, so it shrinks down a little bit, and it starts getting a little bit bluer. It doesn't go blue, but it gets bluer. So if it's a yellow star, it might go to almost white. And then as it finishes the helium, it goes on that asymptotic giant branch, goes up to a supergiant again, and that's the point where it can start making molecules of carbon in the outer atmosphere. And during that phase, the star can lose some mass and give off some of this outer carbon that's in the outer layers. And these small stars, like M stars, well, there's convection going on all the way to the core, so it's literally dredging up all that stuff made in the core and bringing it up. However, these small red stars don't ever get hot enough to make carbon. So it's just dredging up the interior, right? It's the warmer, the hotter stars that actually make the carbon. So it could really mean then that it could really mean that the universe is actually either more populated by carbon, which implies that the template for life could be far more prevalent, and then that would mean that life in the universe could be even more expected under certain circumstances than we know. That, I think, is really the most important part of that discovery. So I hope that can help.
Curtis Horn has some comments for you.
Yeah, he's asking about, he says, are you stacking the Comet? You can do that. You're stacking the Comet. If you stack the Comet, yeah, I'm actually stacking the Comet with 20-second shots, and then I clear it and start again so we can actually get a second position. If that's
He says click on the alignment tab and then check mark align on the Comet.
Let's see. Oh, look at that! Curtis, I didn't know that was in here. So what we're gonna do? We're gonna clear this, and we're gonna say align in the Comet, and we're gonna see if we can align in the Comet.
Learned something tonight.
Yeah, I mean the sharp. I don't know if that was in SharpCat before, but we're gonna find out. I have to look. I'll ask Robin when he put that in. Yes, I was stacking the stars, and thank you for the link, Curtis. I do Comets so infrequently that I forgot about the possibility of aligning on the Comet. So what will happen here is, as the Comet moves in the sky, the stars are going to move a little bit. And, oh, see? Align on the Comet started doing that, so that's not quite right. I'll have to figure out how to...
You may have to update your version.
No, this is the latest version.
4.1?
Yeah. Hey, Hunter. Yeah, this is 4.1.15 something. Okay. Let's clear this and see if we can... If I say align on the Comet... Yeah, I have to figure it out. Yeah, he says it's new for 4.1. I never saw it before in there. Yeah, I just cleared again, so we're going to try it again. So we got this image. And let's see what the next shot shows. The stars should drift a little and the Comet should stay still. But they shouldn't... No, they shouldn't drift like that. Okay. Alright. So I'm going to take that off for now, and I'll figure it out. There might be a way to do this once we get good at it. I will look at your link that you sent and see. Yeah, it should be. Alright, we'll just do a regular stack here for a minute. Uh-oh. Oh, it's still aligning on the Comet. Alright.
He says you need to adjust star filter size and threshold detect.
Yeah.
I want to learn to use that on a private stream and then debut it to the public.
Agreed. It really does deliver fantastic results. Okay. Okay, so now we're just gonna do this. Oh, Starlink. Yeah, thanks. Thanks, Curtis. I'll dig into this. I see that right up here. We have to adjust the ignore filter size, star filter size, and detection threshold values. I'll work on this privately, Curtis. Thank you, though. This is really cool. It is new in this version, and some of the things I just didn't know were here. Nice, nice, nice. Okay, let's back this down. Hey, C&D boy, how's it going? Okay, I need to label this. All right. Yeah, Robin's fantastic. He's added things in the software at my request, which is really cool. Robin's the author of the software that is being used here, that you're seeing here on the screen. I asked him for an autofocus section, and now it does autofocusing for us, which he added. He added a few other things I asked for. And Michael Hedrick says those little stars right here in front of the comet are pretty cool. What's interesting is we'll see the comet get closer to it.
Might pass right through them.
Yeah, it might be cool. Cosmic Ray, the C-Star S50 doesn't have the resolution that we have, so I would probably be disappointed with it because I'm used to what we see here, you know. But I think the C-Star is wonderful for people who don't know anything, who want to get into just taking pictures and not have to think about it. It's good that way. Very good that way. Okay, we're gonna save this. Save exactly as seen.
That's what I thought, Ray. He says he was directing that at me.
Oh.
Ray, I have too many telescopes as it is. And imaging just isn't my thing, really. I just come along for the ride here. I tried my hand at imaging back in the days of film, and I got disgusted and quit when everything went digital. I'm a Luddite at heart. I'm very old school. Kind of paradoxical that I'd be a Luddite since my job was working on multi-million-dollar pieces of equipment.
Yeah. I'm going to clear this and start another set. All right. I'm going to go look at something else to go to here. We're in Coma Berenices, apparently, right there. It's close.
Yep.
Let's...
Michael, the image scale is too close to show constellation. That's just stars.
I've seen the black eye.
Black eye's always cool.
It is. Look at it. Why not?
I don't own a smartphone either, Ray.
Can you believe it, Ray?
I hate those things. I occasionally see their utility, but I've gotten along this far in my life without one, and I have no particular inclination to get one.
Well, he's saying it a C-Star S50, and you might have a reason to get one.
Eh.
Ray, just for you, I asked the spider to rebuild the web there so you can see our weather vane inside. Ufi Otori is with us. Hey, Ufi, what's going on? Nice to see you. Haven't seen you for a while. Just checking in, she says. All right. Yeah.
I have a phone in my house. I still have a landline, believe it or not.
Well, if you ever went on Coast to Coast, you'd be all set because they want you to have a landline when you go on the show.
Huh.
Which I think is crazy. And they've come into the next century, however, because I was on with George Norrie a few weeks ago, and they actually said, well, if you got a cell phone, we'll either let you use Zoom, Skype, or have your cell phone on and connected to us 100% of the time, because they don't want to risk losing you. So that's what I did. All right, let's do this. There's our next galaxy we're looking at. I slid on over to that galaxy without you knowing. Thanks, Ufi. It's good to see you too. All right. Now let's go in here. Now we'll move east a little bit. Ranjit says, I shared... Oops, hold on. Shared an interesting opinion on C-Star. He said, friend did, made things so simple that there was no challenge, no problems to solve, get things... Yeah, and that's great. The C-Star is great, but people don't realize how much better quality they can get. And that's why they say it's so great. It is. It's good.
Telescopes are definitely moving that direction, though.
They are. I personally think that eventually universities will be able to have telescopes in lunar orbit, things like that. I think they'll be able to do that, or Earth orbit even. I think that's going to happen. Okay, 22 seconds on this galaxy. And away we go. Let's get out of low light mode. Go into live stack mode. Sorry, let's do this. Clear this.
The whole technology behind C-Star and stuff like that, I suppose it's an amalgamation of, telescope optics and probably cell phone technology, smartphone technology. And they are moving that way. There are other scopes that do what the C-Star does, I know, and It's just a matter of continuing to develop the tech and increasing the aperture on the telescopes they stick them on. And there will very soon, I'm sure. They've been going this direction for quite a while, though. Like a plug-and-play telescope that with some serious aperture. You can buy them now, but they'll continue simplifying them.
Yeah, I think that's true.
Go-to itself has been such a change in amateur astronomy. Back in the day, you actually had to learn the sky, and that's what I did. And nowadays, you can jump on a go-to telescope and know absolutely zero about telescopes or astronomy, but as long as you can navigate menus on the keypad, well, you can telescope what to do, and it'll go do it all by itself.
Michael Hedrick asked a couple questions. He says news on Betelgeuse or the Nova Star we've been looking at. We're going to look at T Corona Borealis. It has not gone nova yet as far as we know. And he also says the little slit of the moon looks cool. Can we look at it, please?
It's down already.
Yeah, it's too low in the sky this early for our particular observatory. This particular telescope wasn't made to look for the moon and look at the moon. It was made to be a deep sky telescope. The next telescope, however, will be able to see the moon in intricate detail. And that one, like I said, we already bought it. It's an 11-inch Celestron with a Skywatcher EQ6R mount. I got two of those mounts, one for the telescope we're currently using right here, because we're going to change that out. We're going to take it off the forks. Okay, you see this telescope has forks on it, which are hard to kind of see here, but it has forks on either side here. We're taking all this away. We're mounting this to a new mount, and the mounts are going to be identical to each other and allow us to do a lot of really good stuff. So neat stuff. If the Sea Star was $250, then more people would get into astronomy. But at $500, it's at the limit where you might start to think, especially for regular people, that's a lot of money. So I'm going to use this telescope and never get a new one because it costs so much. Hey, Jeremy B., how's it going? Ranjit says sea stars are great for public outreach for schools. That's correct. That's a really good thing for like an astronomy club to have where no one knows anything. In high school, even elementary school, take it out, turn it on, and watch what it does.
As I said, 50 millimeters is 50 millimeters. It's a hair less than 2 inches. That's less aperture than you get on the old department store telescopes.
Well, aperture is required.
60 millimeters.
Yeah, aperture is a required thing. So check out this galaxy. This is the Black Eye Galaxy. Look at that, huh? That's really kind of cool. Really kind of cool. We're going to just drag our black level back a little bit to make it a little more. And then we're going to try and dig more into the details of this nucleus by dropping this down.
The moon is not rising, the moon's set.
Hey, Cruiser67, how you doing?
What you said about aperture, aperture rules.
Yeah.
A lot of people have the misapprehension that telescopes are all about high magnification, and that's not true. telescopes are about light grasp,
Mm-hmm.
and the bigger the aperture, the greater the light grasp. Good old pi r squared comes into play.
Mm-hmm. Yep.
And Pegasus isn't even up yet.
Yeah, when it is, we'll do the Andromeda Galaxy and the Triangulum Galaxy a little bit after. This galaxy here, you'll notice it has the this black eye type of look. That's a dark lane that is particularly strange because it's only on one side of the galactic nucleus. Typically, they're distributed more evenly. So why does it look like that? Nobody really knows. Maybe an interaction with a previous galaxy in its past. Not sure, but it is something else.
I'd rather fight than switch.
I was waiting for that.
Yeah, I know.
That's why I was letting you. I was waiting. Cruiser 67. I think you've been writing me in email before, and I want to thank you for that. It's good to have you with us. Thank you for stopping by. And I want to say hello to everyone who is a Patreon member for us. We really appreciate it. We are a non-profit organization, so we do depend on support. So if you think about it, maybe there is a way that you might want to join our Patreon. So please consider becoming a Patreon member and supporting us. We definitely need support. You know, it's actually we do it because we love it, but we also do it to be able to do more for everybody and support everything we're doing. This is not a hobby for us. I'm a professional astronomer. This is what we do. It's our living, and we would like to be able to get you the best equipment to show you the best things, and that's what we're doing. We've already got we have the second telescope going into Benson, Arizona, 200 miles to the southeast of the current one, which is this one above. Which is the one above us is actually out in the middle of the desert, in the Sonoran Desert, west of Phoenix by about 80 miles. And the one we're putting in is going to be in Benson, as I said, 200 miles southeast. And we're doing a third one, which is here. I'm in Connecticut. And it's going to be about 100 feet from me here. And it's going to be a solar observatory. So we'll be able to study the sun and everything going on the sun. And that'll be pretty cool.
Oops, will you excuse me a moment, please?
Sure thing.
Right back.
Okay. Curtis says, my other daughter's scope is a 6-inch f4 Newtonian. Oh, very cool. It drives with ASI Air. That's a Wi-Fi methodology to control the telescope, and that's cool. Autofocus go-to mount. Every kid should know how to run a go-to mount. It's actually simpler than other things out there. Look at this galaxy. Wow. That's looking pretty. Let's see if we can soften some of the noise. Yeah, look at that. Wow. It's really showing well. Let's go back here. We're going to come off the peak a little bit. It'll lighten up things a little bit. Wow, see that? That's beautiful. That's just a gorgeous galaxy. Wow. I'm impressed with that. Vincent's Virtues, how are you? I know we've talked before. It's good to see you back here, man. Yeah, Curtis says, very nice view. This is really cool. Mr. Django says, beautiful, love it. Fantastic. Oh, that's excellent, Vincent. Thanks. Okay. By the way, you all hear the music tonight, right? Curtis says, Mark, FYI, you just needed to turn on highlight detected stars to make sure the comet was the only one detected. Ah, very close. I'm going to go back to it, Curtis, and we'll give it a shot. Mr. Django, I think Ray is from Ohio. I could be wrong. Maybe Pennsylvania. Cindy Murphy, how come I didn't see you here? How you doing? Thank you guys for telling me about the music. I figured out what was wrong with it. Oh, Ray lives near the beautiful Mount Airy Lodge in the Poconos. Very nice. Very nice. Yes. Okay.
Okay.
Welcome back.
Thank you.
When we go back to the Comet, we might have a hint thanks to Curtis about how best to carry out this Comet tracking.
I see that.
It's interesting because in this new version, I have yet to get through all these things. I found a couple of things I really like in here, and I started using them. But there's more things in here that are really nice. Like under enhancement, okay, color noise reduction is really cool because if you don't use it, okay, then you get an image that's a little bit more rough like that. See, that's a rough one. Add the color noise reduction, and look, you get an instant 100% better view because you're removing color noise, which is great. Look at this, Daryl. That's pretty.
Yes.
All right, Black Eye Galaxy 34. We're going to save it here and go back and save exactly a scene.
Can we zoom in on that a bit before we leave?
Yeah, I'm not going anywhere.
Oh, okay.
Sure, let's zoom in. Wow. Let's go back to histogram. And let's go down here. Let's pull this way down.
Just did, Sam.
He might be behind us a little. Because he's watching the view. The chat comes in instantly. He's watching on YouTube. Hey, Prowl, what's going on? Nice to see you, man.
Long time no see, Prowl.
Yeah, nice to see you. Yeah, that's pretty cool. Let's see where it wants to go with its processing. Yeah, see, this is what the program thinks it wants to do. Well, I don't want to do that. I want to bring this way down to get rid of that background because I'm using a setting here of 250. This gain is the most important value along with the exposure. If we set this at 50 and took this exposure, we wouldn't see all this noise. So it's pretty cool. Boy, Cosmic Ray's really pushing the sea star on you. I wonder if he's getting kickbacks. I think he has a sea star.
I think you're right.
Okay, this is really pretty. I can see detail now in the dark, in this dark lane here. See right in here. Look at that, right in there. Look at that detail in there. You can actually see detail. I like that. Right in here. You can see this detail in there. It's got various grades of detail in there. That's pretty cool. I like that. We'll save this one more time. Save exactly as seen. All right, now when I save this, what's happening is right away what's going on is it's being saved to the cloud and saved to our server. So within 30 seconds, it's available for you to download, and you can download it for free. Where? Well, you got to go here, SkyTourLive.org, find it, and then there's instructions how to do that. And then you can go and do that. Let's go back to the Comet for a minute, because I'm going to try doing what Curtis suggested. See if we can do this. There we go. There's the Comet. All right, and we're going to center it up, and then we're going to try to align on the Comet itself. It's a new feature of the software. We're going to give it a shot. Okay. All right. So we're going to just try this and see what we get. We'll make this a 20-second shot. All right, off we go. Get out of low light mode. Go into our stack. Clear the previous image, which is beautiful, of the Black Eye Galaxy. That's beautiful. Look at that. Wow. Jeez, that's a nice one. Okay, under alignment, Curtis said we're very close. Unless if I say align on the Comet. I gotta go back and look at this comment about where we have to go. We'll try this. Turn on the highlight detected stars option. Highlight detected stars. Do you see highlight detected stars?
No.
I don't either. Oh, there they are. It's over here.
Oh.
Yeah, if I say align, shouldn't I see these? Oh, look at that. We got a tumbling satellite right there.
Uh-huh.
That's cool. Okay, so it's seeing that. I should probably see more boxes.
You want the box around the nucleus of the comet, don't you?
I think I want the. I think I want to see the stars that it's detecting.
He says highlight detected stars
That's there.
and check that the box is drawn around the nucleus of the comet.
Oh, well, it's not. It is not. Yeah, so it's not doing it right. Start again. Try to put the comet in that box. Do I actually move the comet to fit in that box? Is that what you're saying? No, I can try that. Let's first... Yeah, see? That's kind of weird, but let's see if that's actually in the center. It's not. It's not actually in the center. Okay, that's strange. Okay, let's try this. Alright, let's go back to 1 second here. Let's go here. And let's go here, and we'll move the comet into the center. The comet's right there, so we're gonna actually... I don't think this is what's needed, but maybe it is. I don't know. We'll try it. Okay. Okay, no reticle. Now let's do a live stack again. Try with this 1 second here and see what we can do. Oh, look at that. It's doing something. Incorrectly, but it's doing something. Alright, maybe I need to, oh, sorry, I got this on. Let's try to make this a 15-second shot. Try that. Comments up there now. Let's color correct that and do this.
Almost.
Yeah, I don't... It's up here, though. I mean, I'm doing this blind. I haven't even read how to use it. I'm just looking at what Curtis is saying, you know.
So the box is fixed. You need to
I don't know if I can move it.
center the comet in the box.
Well, I mean, I guess if I... Yeah, see if I zoom in. Clear. We're going to find out because I'm going to try this. Oh, see, the box moves with it. No, that's no good. Alright, I'm not sure how it works.
I assume you need to move the comet so it's inside the box. Isabella's here. Hi, Izabela.
Hello, Izabela. Yeah, you can't, Alright, I have the comet to center the frame. See, now it's in the box, but it's not really in the box, so I'm not sure if it even sees it in the box here. But probably these things need to be set. Yeah, see, it's not even working. How about optimize for faint stars? What's that do? If it did anything, it would doesn't pick anything. It doesn't allow it to be checked. All right. This is apparently not checkable. Yeah, okay. It's in here where there's something I've got to work on. Detection threshold. Let's let's lower the detection threshold. See if that makes a difference. That's one shot. Let's see what happens. Probably gonna do the same thing. All right, let's see what happens. If this doesn't work, I'll come back and try another time. All right, didn't work. Okay. I'm glad it's there. We'll figure it out. Okay, so let's just do a straight shot here again. Let's we'll call it A3 here. That's the Comet. Oh, look at that.
Now you've done it.
Well, and now it's highlighting detected stars. So if I say a line on the Comet now, what's going to happen?
Curtis has a request. I still want to see M104 before it gets too low.
Yeah, good idea.
Curtis would like to see EDC 4725. It's near the black eye.
Okay. I think we can do that. All right, let's get this underway here with this. All right, well, it's not working. I'll come back. All right, why don't we do that? Let's go NGC 4727. Is that what you said?
4725.
Okay, let's see. NGC 4725. Whoops, sorry. 25. It's not far away. Okay, this is an SAB galaxy. It's an active galaxy. Let's check it out. First things first, let's go back to alignment and turn off align on Comet. And we'll clear it. Now we'll get rid of this. All right, and we'll go into our other mode here, low light mode. Okay, low light mode coming right up. Okay, let's go back to this, our planetarium, and let's say go. Magnitude's 12.44. We're going to check it out. Zumba. There we go. There it is, right there. It's pretty good there, Curtis. Dead center. Yeah, I'll see if unchecking. Where's Cosmo? Where's he writing? Cosme? Where is he writing? Let me see what he writes.
I think it's a
Oh,
she.
okay, maybe, okay. ¿Cómo está Nave Espacial Satellite Special Paraments? Oh. ¿Cómo está, Cosma? We would like you to, if you can, type in English, because there are people that don't understand. I'm not sure if you're Spanish or Portuguese, so let me know. I don't want to insult. I'm just curious. We're going to do a 25-second shot here. Here we go. And it's underway. And we'll go to our live stack now. And Izabela, we are going to go to the Blaze Star. Absolutely. It's pretty much overhead right now. We will. We're checking out a few other things. Oh, hey, look at that.
Oh,
Curtis, that was a nice selection, Curtis. Well done.
very, very nice.
Curtis Horn suggested this, folks, and so we are there. And we're going to optimize this. For our view, we're going to color correct it. Okay. Oops. Yeah, you're right, Curtis. I gotta turn off detected stars. However, that's actually kind of cool. You know, highlighting detected stars is helpful at times. It's not a permanent thing. Now we'll it detected the nucleus of the galaxy as a detected star.
Yeah.
That looks like a barred spiral to me.
Yeah. Looks almost like one of those steering wheel galaxies.
Steering wheel galaxy, yeah. It is an SAB, so it's capital B, so that's actually a the B, capital B means barred spiral. Yeah. And 4747 is at the upper left, which is this one. Well, you know what, Curtis? Here's what I'll do. I'll annotate it. So this is the previous annotation. Now we're going to do a new annotation for what we're seeing here and get all that in there, and then we'll save it as annotated.
Why does it say 45?
Just
65?
because it's the old annotation. We got to let it find a new annotation.
Oh.
Now it doesn't. See, that's
There you
had
go.
to give it a shot. Okay, so this is NGC. There you go. Okay, NGC. This is 4725. Yep, there we go. That was a good call, Curtis. And we'll let that come in a little bit more. I'll try and drop some of the noise here a little bit. Now we'll save the annotation of the image. So that's saved, and now we'll get rid of this for now. But bringing it back, let's just look at it quickly. So 4747 is there. 4712 is here, and 4725 is here. I'm going to guess that these two are further away, and 4725 is closer.
I would guess that, if I remember correctly, NGC numbers increase going west, east, and right extension, don't they?
Yeah, I'm just wondering which one's closer. I think this one's 67 million light years away. 4747 is where's this distance? Oh, did I say 43? Looks like 43 million. So it looks like this galaxy is actually further away. How about 4712? That 252 million light years. I would check 4747 to see, because it's saying here it's 43.7 million light years, and 4725 is 67 million light years. It's possible this is a small galaxy closer than this, but why don't you check, see if you can find 4747's distance versus 4725. This is pretty. Curtis Horn, good call on this. This is a nice galaxy. Shows well too. Creeptasia's with us. Hey there, Creeptasia. How you doing? Nice to see you, man. Thank you for showing up and saying hi.
Intermediate barred spiral galaxy, prominent ring nucleus, located in Comet Berenices, near the North Galactic Pole.
Mm-hmm.
Pretty pictures of it.
Yeah. Curtis, yes.
Distance,
I want to know how you found it, Curtis.
Wiki says 40.1 plus or minus 6.2 million light years for 4725.
Make did a close flyby in 2016, and that's how Curtis discovered 4725. Nicely done, Curtis. That's really, really beautiful.
The other one was 4727?
4747. The one in the upper left here.
Oh, 47.
Yeah, 4747. See, here's the annotation. 4747 and 4712.
Again, it's just Wikipedia, but it says about 35 million light years from Earth. So it does say that it is closer than
this one.
Yes.
Okay, so that's
4725.
So that's got to be a smaller galaxy then overall.
35,000 light years across.
Mm-hmm. Oh, that is small. That is small. That's small. Let's see here if we can get a little more detail out of this.
(4725) is a pretty galaxy.
Yeah, it looks like it's had some interaction with something else too, because it looks a little bit irregular down here. I'm wondering if there's been some irregularity in here.
They do show that. It's the other pictures I saw. Hang on just a second.
Now this one's going to become a staple for us because this is really pretty.
Yeah.
So we'll thank you, Curtis Horn, for turning me on to this. This is actually quite nice.
The lower limb of the galaxy, the spiral arm, does look kind of extended or pulled on, like it went through a gravitational interaction or something.
It does, doesn't it? Let's zoom out and see what else is in here. We don't have anything else. Let me color correct. Okay, and that's amplifier noise on this side. We get rid of that. That's what our... Okay, now let's see here. Let's see what this wants to do. It's probably going to close it up. Yeah, I thought so. Yeah. I'll move this down a little bit again.
That's very nice.
It is. Nice trio of galaxies, actually. You can see these blue stars here. This is young hot blue stars right there. Right there. You can see the extended bar in the center of which the spiral arms come. That's really pretty. And there's additional stuff out here. Seen that?
Yes.
Really cool. All right. Well, we're going to save this right here. This is 21 shots right there, 21 image stack. Save exactly a scene. Well, we will add this to our list. This is a really good one.
That's cool, Curtis. Thank you for the heads up on that.
Yeah. Well, see, that's what SkyTour LiveStream is about, guys. If you've got something you want to see. Yeah, it looks like a Romulan battlecruiser. You're absolutely right. You're reduced 2 steps in rank. Return to your post. Cool. All right. Let's see now. We're going to come back here. And now we're going to go to T-Core Bore, which is the Blaze Star. We're going to check that out. Right there. All right. It's going to be pretty high up. We're going to go for it right now. It's 72 degrees above us. You'll see the telescope is going to lean over a little bit and look at Corona Borealis. We're going to do another identify, and then we will find the Blaze Star. So when you look at these, you say, well, where the heck is the Blaze Star? Well, there's the Starlink right there. However, let's do that. So we click this. We're going to see the old ones. And I'm going to tell it to do I'm going to tell it to do the identification now, and it will show you exactly where the Blaze Star is. There it is, right there. And we're going to go north now. And the nomenclature doesn't come with us. The reason it's called a Blaze Star is because it goes nova every so often. It's a well-known time frame, and it's right around 60-something years, and we're right about there right now.
80 years, I believe.
Oh, I thought it was 64 or something like that.
I think it's 80. About.
All right, well, I don't remember that. I thought it was something. All right. So there's the Blaze, and we're going to stack it. We're going to do 20-second and enter and go stack it. Oops, got that going. Okay.
While it's stacking, can you go to Stellarium for a moment where it is?
Yeah. All right.
Okay, can you back out some? Show the constellation.
It's Corona Borealis.
Yeah, you see it's the orientation looks kind of funny. That's just the program, I guess. You see it's a crown shape of, looks like 6 or 7 stars. Alphecca there is the brightest star in Corona Borealis. And as far as the curve goes, it's to the lower left, as I've seen it in other images, but it's yeah, it's to the lower left of Alphecca. Let's put it that way.
When you're looking at it on the sky right now, because there's Alphecca right there.
Right. Alphecca is sometimes called Gemma, which is the jewel in the crown.
Okay,
Michael, yes, Nova can repeat. It's a nova, not a supernova.
Yeah, right.
And repetitive nova like this, there's a white dwarf orbiting a red giant. the white dwarf is pulling matter away from the red giant and it's landing on the white dwarf. It's mostly hydrogen, and when it builds up enough hydrogen, well, the white dwarf goes nova all of a sudden. Big thermonuclear explosion on the white dwarf, and it gets bright for a while. And it happens on about an 80-year cycle. It's the last numbers I saw.
The process that's going on is actually a delicate balance, Michael, because what we're looking at is, as Daryl just said, it's a red giant star, and the white dwarf are orbiting relatively close to each other. So when the white dwarf was a regular star and the red giant was a regular star, they were orbiting each other like normal. But one of them used up its hydrogen first and swelled into a red giant, and then collapsed back down to a white dwarf over time. Then the next star evolved and swelled into a red giant. But now there's a problem. That red giant gets so big that it's actually feeding matter through the common center, the common rotation point, and that lands on the white dwarf, coating it, as Daryl said, in hydrogen gas. Then there's a magic number called the Chandrasekhar limit, and that Chandrasekhar limit is 1.44 solar masses. If the white dwarf is smaller than 1.44 solar masses, then you can get material falling on the white dwarf for some period of time. And if it doesn't reach 1.44 solar masses, then what you can get is that the hydrogen gas on the surface of the white dwarf could spontaneously all fuse into helium. And that's the part that makes the star get really, really bright for a period of time, and then it fades again. And that process will continue until the red giant shrinks down into a white dwarf, and then we'll have two white dwarfs orbiting each other. Now, on top of that, if the red was a little bit more massive and was like 1.435 solar masses, and 0.05 more mass was bled onto the surface of the white dwarf, making it 1.44 solar masses, well, then what we would get is a Type 1a supernova, where the white dwarf would not just fuse, it would also be past that critical mass, and it will try to collapse at the same time as it's trying to fuse, and that will cause this total what they call disruption of the star, and that leads to the supernova that would occur. And Type 1a supernovae are really cool because we know how bright they're supposed to be. They're kind of like standard distance candles. So when we see a Type 1a supernova in the galaxy, and we can tell what they are based on their spectrum, then we know how far away it is, because we look at the apparent brightness of the nova, and we know how big it is if we put it at our standard distance for calibrating distance, which is 10 parsecs. And based on that, and knowing the difference between those brightnesses, we can see how far away it is. And that's really cool. Oh, thanks, Curtis.
If the blaze star does exceed the Chandrasekhar limit, it will, as Mark said, go supernova. And what you'll have left is either a neutron star or a black hole.
That's right. But you have two stars there, so it's it's complicated, because the red giant may not be destroyed. It may still last, and then you'll have potentially a neutron star orbiting a red giant. When the red giant shrinks down, now you're going to have a potential white dwarf orbiting a neutron star, or that red giant could go supernova on its own because it's more massive, perhaps. And then you'll have two neutron stars orbiting each other, and that leads to things like neutron star collisions, possibly, over time, and that's what's really cool.
I read somewhere that when the nova does happen, it may only be visible for like a week or so.
Yeah.
And it's currently at 10th magnitude, and it's thought to it will brighten to about second magnitude when the nova occurs. It'll be bright for about a week or so, and then it'll fade away again.
Yeah, and that is consistent with a star that is going through a rapid fusion process on its surface. This runaway fusion process is what people will see as this brightening. You know?
Excuse me.
Yeah. So we have nova, we have supernova, we have kilonova, we have hypernova. Each one bigger than the previous.
I'm gonna check that real quick.
All right. Also find out what the period is on this nova. I thought it was 64 years or something.
Stand by.
Telenova. Okay. I thought Telenova was a TV station.
I think it's a.
It's Ray's funny, Bossa Nova. Hi, Brandon Hill. How you doing? Brandon Hill asks a great question. To get the standard of measurement of distance and luminosity for a Type 1a supernova, how did we perform the first measurement to know this relationship? When we saw the first 1a, we saw the first supernova from a white dwarf orbiting a red giant, we didn't know this relationship. So we just saw and said, "Oh, that's interesting. This supernova was at a certain distance." And so after reviewing multiple similar supernova, again seen by the spectrum, we were able to say, "Oh, there seems to be a relationship." We had to see multiple ones of these, Brandon, before we could actually make this connection. But once done, we were able to see that, yes, indeed, Type 1a supernova have a relationship, just like Cepheid variables. We didn't know how Cepheid variables could tell us the distance to galaxies, but there's a relationship between Cepheid variables and their rate of change and their distance and their brightness that they get to. So that's something else that we had to look at multiples of these to see, and thus, through study of multiple recurring supernovae and Cepheid variability phases, we were able to see that this relationship exists. And I want to say hello to Kathleen MC, Kathleen Mick something. Hello, Kathleen. How are you? Thank you for joining us. If you haven't subscribed to us, please do. And we would love to see you. And she is from the CR Fox. Is that Crazy Fox? I'm not sure. CR Fox channel. Nice to see you. Yeah, so once again, this is the Blaze star. This is the recurring nova. That's a galaxy sitting next to it. That's why it's labeled. So quite interesting. You know, really, really nice. I really like that. All right, let's save this. Well, first of all, I'm going to save it with the annotations too. So let me just bring that up. Save image with annotations.
Roughly every 80 years.
Okay. And now we'll save it normally. And we'll save as exactly as seen. All right. So there we go.
Is it the red one in the middle there? Just above center?
Yeah.
Okay.
Oh, Kathleen, you're talking about Dr. Fox. And you said CR Fox. I wasn't sure what you meant. Dr. Fox. I know Dr. Fox. He knows me. We're good. We're good buddies. Yep. Dr. Fox probably is covering the new eruption in Iceland right now. Because I really find his channel to be the best. I'm always promoting Dr. Fox. In fact, sometimes he comes on our channel as well and hangs out with us and says hi.
I saw a video of that in Iceland a few days ago. Like the ground split open and
Fisher?
had a huge curtain of fire.
Oh,
yes,
wow.
a huge curtain of fire was running like the length of the fissure.
Oh, that's like a flood basalt, those are called. And those are dangerous. In the Permian period, 252 million years ago, there was a lava cap theorized. And so what happened was a volcanic eruption in the Siberian Traps region. There was a lot of permafrost, a lot of frozen ground, so the lava moved horizontally under the ground, and thus it was pushing through all this organic material deep underground. And as it was annihilating it, it was creating lots and lots of carbon dioxide. And it pushed out in all directions around the source of the lava throat there. And when it reached the edge, it could come through a thinner ice sheet and started popping through in various regions. And it eventually ended up making such a massive, explosive eruption, suite, if you will, of eruptions around that volcanic caldera for miles around. It threw many gigatons, that's billions of tons of carbon dioxide into the air. And over just a few weeks, the Earth's temperature rose by 21 Celsius. And that was responsible for 96% of all life on the planet dying. And that was the Permian extinction. So volcanoes have shaped life tremendously on this planet. You know, I think that's really cool. I've talked to Dr. Fox about this, in fact. So, yeah, I enjoy his coverage.
I've been watching Geology Hub channel on YouTube some recently.
Yep.
He covers volcanic eruptions.
Yeah, see, in astronomy, we have to understand Earth science because volcanoes inevitably are the source of the early atmosphere on the planet, and they are the source of possible life on this planet because they're spewing out material from the interior that eventually goes into the into becoming an atmosphere. Atmospheres don't just form, they're expelled from inside the planet as it's cooling. And so based on the chemistry that goes on, we will either get oxygen or not. We'll get lots of water if it's a heavily water vapor laden atmosphere, as on Earth. Venus had a heavy water laden atmosphere at one time, but it could never rain on Venus, so those molecules never got a chance to condense and form droplets, which is kind of bad. But they did combine with sulfur and make H2SO4, which is hydrogen, sulfuric acid. And that sulfuric acid vapor is what is so caustic on the planet. It is just the wrong place to be at all times. Pressure on the surface is 90 times what it is on Earth. Temperature on the surface is 900 degrees. All because it couldn't rain on Venus. Had it been able to rain on Venus, a lot of that moisture would have rained out of the planet's atmosphere, making it less dense and starting a proper carbon cycle, water cycle, methane cycle, and so forth. And that just never happened on Venus, so its atmosphere has stayed quite dense and deep.
I've seen some talk that some think the Venus is still volcanically active as well.
Yeah, I saw some of that as well. We're going to clear this one now and go back to our low light view. All right. There we are. All right,
So I
let's.
assume that was actually. See, the image looks like it's shifted or something.
No, it's okay. Here's our view in our all-sky camera right now. You can see the Milky Way rising over here. These are the lights of Phoenix, Arizona, 80 miles away. The camera's very sensitive, so we can see all that. This is really something. Moon is minus 10.79 degrees down after where it was. Only 3.6% illuminated. Temperature's 109 on the sensor, Fahrenheit. So inside the box. Temperature was up to 150 in the sensor earlier today. Okay. All right, so let's do one more object.
M104.
All right. Do you all concur? M104, Sombrero. We looked at that the other night. It's not far away. Yeah, it's down here.
Just west of Spica,
Yeah.
if I remember correctly.
Yeah, there it is. Okay. Let's do
All
that.
right, Mark, excuse me again just a moment, please. I'll be right back.
Okay, we'll be right here. Okay, folks. Creeptasia says that Billy Carson said the planet Nibiru circles our solar system every 3,600 years. Do you think the giants will come back and restore functions of the pyramids? I don't think any of that, actually. To be fair, I think that I was on Billy Carson's show once in the past, and he seemed like a normal guy, but he had a interesting take on things. Mr. Django, thank you very much for dropping by tonight. This will be our last object tonight. Yeah. I think Daryl's back.
Yes.
All right, let's we're gonna wait for this to stabilize and see if we need to refocus.
This is completely off topic, but we're presently experiencing one of the unique facets of living in the wonderful state of Colorado. We're presently in the midst of the annual Miller moth migration.
Oh yeah.
They're just inundating the place. And they get into everything. They worm their way through tight spaces. I have been keeping my doors and windows closed, and they still get in the house.
Wow.
I do the old trick of filling the kitchen sink with water, put a little dish soap in it, and leave a light turned on overnight over the sink.
Wow.
And 3 mornings back, I had 12 moths in my sink. The next morning, drowned. And the next morning, I had 18 moths in my sink. And this morning, I had 12 again.
Wow.
And they're gross.
Well, because you got them in your sink.
Yeah, somebody has to fish them out.
How big are they? Size of your thumb?
They're
Are they that big?
moth-sized.
Okay. Do they drink Miller Lite? Cosmic Ray asked.
Huh?
Do they drink Miller Lite? Cosmic Ray asks.
Probably. Actually, they fly up into the mountains in summer up there, and they drink nectar from flowers.
Mm-hmm.
Then they fly back in the fall.
All right.
They go out on the eastern plains and do their little moth thing and lay eggs underground, and they turn into army cutworm larvae, which feed on vegetation out on the plains. When they return in the fall, they're so predated. Everything eats these moths like crazy. Bears love them because they got such a high fat content. Birds eat them.
People. I bet people fry them and eat them like fried grasshoppers.
Not that I know of. But they get into everything when they get indoors. They burrow into clothing and cereal boxes and you name it, and they die. And then because they're mostly fat, they turn rancid. And they stink.
Keith Evans, thank you so much. That's very kind of you. If you want to join our Patreon, that would be wonderful. I mean, I love the fact that you're joining us. Thank you so much. That's outstanding.
Michael H., the tarantula migration happens later in the summer. We do get the annual tarantula migration too, though. All the boy tarantulas go out looking for girl tarantulas, and
yep,
they carpet the roadways and get a lot of squished tarantulas. Nice galaxy you got there.
I know, this is Mesher 104. Everybody appreciates it but Cosmic Ray. As expected. Keith, have you been watching us for long? Have you been lurking and watching our stuff over time? Tell us about yourself. Where are you? Where do you live? What state? You're one of the SkyTour family now, buddy boy. We appreciate having you around. We were actually out. I wasn't, but the SkyTour folks that maintain this, Tara and Marianne and Tara's husband Dale, were out in the observatory doing maintenance a few months ago, and Marianne, a cop, police officer, not supposed to be afraid of anything, has got me on the phone, and we're doing a telemeeting because we're trying to get some things underway, get the telescope reinstalled after maintenance, and all of a sudden she starts screaming and running, and all I see is this on the screen, moving around as she's running away. What's going on? And I hear people in the background laughing. And of course, it was Dale and Tara laughing because there was this cute little tarantula the size of your hand hiding under the computer. And of course, it freaked Marianne out and she started running. And Dale just reached underneath and let it crawl up on his hand, and he took it. I got pictures of it, and then he put it outside because he was actually trapped in there. He couldn't get out, so he saved his life. So I think that's pretty cool, At
least Marianne didn't start shooting.
Yeah, no, because the telescope was too close. We don't want any ricochets. Keith Evans says he's been listening to us for about 8 months from Arlington, Washington. Arlington, Washington State, or Arlington, Virginia, in the Washington area. Sorry, it's a clarification because I don't know if there's an Arlington, Washington. If Arlington, Virginia, I've been there a lot. working for the Navy. I've been down there doing a lot of special project stuff.
Michael Hedrick says Washington State.
If that's what he's saying, yeah. Maybe that is. Okay, Washington State. Very cool, Keith. Thank you. I like to have a good reach with the SkyTour LiveStream. We all appreciate it so much. And so thank you for that information, and welcome to SkyTour LiveStream. This galaxy always looks weird to me because it looks like this disk is sort of like almost translucent. Like this is really rigid here, and it's almost like you're looking down and into a bowl. The illusion created by this bright nucleus.
Yeah.
Kathleen says she's in NY, New York, so we have coast to coast. Oh, very cool.
And as Curtis says, it reminds a lot of people of Sombrero, so they call it the Sombrero Galaxy.
Yep.
If you could see this in other frequencies of radiation of light, you'd see there's two big, huge lobes coming off of this thing, one above and one below. I think is it radio energy? I forget.
Is it a supermassive black hole jets, north-south?
They're not jets. They're big round lobes.
I think those are radio lobes coming off this galaxy.
Yeah.
Yeah. But radio lobes are radiation.
Of course.
So there's probably something to that. I'm not sure.
Actually, the Milky Way has similar radio lobes.
Yeah, you're right. It does. Fascinating stuff. I'm going to make a note here that this is M104, a Sombrero. And we have 16. We'll save it right now. And it's saved. As soon as I hit save and save exactly as seen, give you an example. This is the image that is saved out on the server. Boom, this guy. So you can download this and look at it and use it for anything you want. This image is free. And if you want to know where to get them, all you have to do is go here, SkyTourLive.org, right above my head here, right up there, and check out everything you can do on that page. You can go to our SkyTour LiveStream, which is this stream you're seeing. You can go to our Patreon, which a number of you have. You can go to our gallery. You can go to the server and get pictures for everything we've taken pictures of for the last couple of years. You can go to the fine arts section where you can actually buy highly processed, beautiful prints on framed under glass, on canvas in a variety of sizes, in on metal, printed on metal. You got all kinds of options, so it's really cool. And you'll notice that Izabela in the chat is very, very prolific with giving you our links and so forth. I also want to mention that Izabela has created an app, and it is every observation we have made with the SkyTour LiveStream telescope since 2021. And you can literally search for every time we image this, for instance, and go see all the images. So it's pretty cool. You know, and that app we're working on seeing if we can get it to be available for Apple and Android, and it's it works on all of these now, but we only have it in a test mode right now. And Izabela's been doing some really hard work. Everything you see here will be on that app in the next couple days because she will put it up there. The app is called SkyTour Skygazer's Companion. So that'll be available hopefully when we get it all done. Yeah, it's not out yet, as Daryl says. But we're working on it, and I gotta say, Izabela's put some hard work into it, and
She has.
it's really stunning. Yep. Testing improves her pain. Yeah. Yeah. We actually we're working on a way to get it out there to the public, and we don't want to. This isn't something we expect to make money on, but this is something we want to be able to make available, so people can search our database and see all the times we looked at the Pleiades, and do research. You can look at all the times you look at the Pleiades, and eventually you're going to be able to do things like show us things that don't belong in any of the images. In other words, what's there that wasn't there in other images. So you can discover asteroids, you can find stars that are missing, things like that. And Izabela has found most of those things, asteroids especially. So it's pretty cool. Yeah, really cool. And we're very, very proud of Izabela. And she is the kind of person that we should all try to be, I think. I want to be someone that's going to be always remembered as someone that was doing outreach and giving out to everybody rather than taking. In this world where everybody takes, I want to give. So anyway, to all of you who have added to our SkyTour family in every way you have, I want to thank you, because that drives me forward, and I know it drives Daryl forward too.
Izabela's going to be running this place someday.
She may, but she'll have to answer to Marianne and Tara. But that's all right.
When you look at the Sombrero here, imagine you're looking at NGC 4565, but it's tipped open just a little bit more.
So instead of being on edge, it's kind of like that a little bit. I'm doing it with my hand. You can't see it, Daryl. So it's kind of, we're looking at it just a little over the edge, over the top. So we're looking down on top of it by a slight amount.
Yeah. But the Sombrero, actually, I don't know how you would describe its morphology and the classification system at all, but it's a lot fatter than 4565 is. It has more of a halo. It's fatter than 4565 is, which
Yes.
is 4565 really is quite a flat galaxy. And this would, there's a reason, again, they call it the Sombrero. It's much more extended around the nucleus.
Mm-hmm. Yeah, and it looks like it's more of a round galaxy. From the top, it looks like it might be more round. Interesting, too. It looks like a classic UFO shape. Let's see what this looks like. We've got 33 captured here. All right, and we'll save it. And save exactly as seen. Well, so right now that photo is making its way to our server, and that will be the last image for tonight. And I wanted to thank you guys for coming out and joining us. Daryl, it seems like tonight went pretty quick though, huh?
Yeah, we're about 2.25 hours.
Interesting. Okay. We are streaming to YouTube, of course. We're streaming to Rumble. We're streaming to Twitch, Trovo, Twitter, X, and of course Instagram. So you can find us there anytime. Bonnie's been lurking. See, because look, Anahata 77.
Yeah, I see that. Hello, Bonnie.
Hi, Bonnie. How are you? Yeah. She always says goodnight to you. She never says goodnight to me. Hey.
She likes me.
I know.
She's a nice person.
She is. Maddie Waddy, what's up? And Marvin, hey, thanks, man.
Thanks for coming, everybody.
Rascally Rabbit, and thank you. I see Bonnie. Thank you. We love you, Bonnie. All right, so you guys have a good night, and we will talk to you the next time we stream. And we try to do it every clear night. And let's take one more look at the night sky out in the desert. Oh, it looks pretty good. So here's the Milky Way coming up. So that's nice. This is the new...
There's the Northern Crown right there.
Can't miss it. It's right here.
Yep.
If you want to see it, we just click this button. And there's Corona Borealis.
Yeah. If you can find the bright star Arcturus there, if you do the old trick about find the Big Dipper, follow the curve of the handle at Arcturus, look just to the left or upper left of Arcturus a little ways, and you'll see the Northern Crown.
Right there.
And there's Alpheca right there, the bright star.
Right there. And T-Core Bor is right here.
A little bit farther south.
Yeah, it's close. Yeah. And then we have Hercules over here with the great cluster in Hercules. Measure 13. And when this is available to all of you, and I make this the website, you'll be able to go in here and do what I'm doing. Go here, click on this, and it'll take you to a server showing you more details about what we're looking at. It'll be a wonderful night sky tour thing. So it's pretty cool. Yep. All right. Well,
Thanks for having me on tonight, Mark.
Yeah, it's been great. We'll have a great time. Here's the Keystone in Hercules right here. And here is Measure 13 buried in here. You can barely see it. So, yeah, we will be back on the next clear night. I hope you guys have a good evening. And we will see you on the flip-flop. Good night, everybody.
Good night.
See you guys.